I see some faces here in the room who were there also, and artificial intelligence was definitely one of the major topics there. And if you got young children, please let them study data analytics or big data or artificial intelligence, because there will be a big shortage in the coming months. Gartner said that today, worldwide, we got only 1,250 experts, real experts, in artificial intelligence. In Paris, only 15. So what does it mean for Brussels? Or for Belgium, probably 6 or 7. And guess what? We got them all here tonight on the podium, which is a great thing, isn't it? We got a very tight schedule tonight. It's only 15 minutes. It's a TEDx format, so 15 minutes for each speaker. And we will hope that each speaker will also respect that time. We go with the first speaker. It's Hugues Bersini. He's a professor at Université de Belgique. And guess what? He had already an artificial intelligence lab, back in 1980. So it was already called 30 years ago, Hugues. Yeah. Artificial intelligence. I look like a dinosaur. You look like a dinosaur, I wouldn't say that. Please come on stage, Hugues.
So since I'm the first speaker, let me check if everything is working all right. So I have to press there, and I'll press somewhere in order for my slide to move. All right, if I press them. Okay, good. So thanks for the organizers to invite me. I'm pretty delighted to see that amount of people for artificial intelligence. And indeed, it's not a totally new topic. It's a very old one. You know, the first conference in AI was in the 50s, and I can tell you that everything was invented at that time. So not a lot has been invented yet. But it's interesting to understand why it's such a hype. You know, well, in my long career, my lab was created in the 80s. There's been a lot of hype in the 80s with neural network, in the 90s with data mining, CLM, and now with big data, deep learning, etc. So I'm trying to understand why this hype this time. And I guess there are maybe 3 reasons. And the third one will be the topic of my talk. But the first 2 reasons is, first, the GAFA. Obviously, the GAFA is making a huge hype around artificial intelligence. For the main effort they're doing, the main research they're doing is to force people to click on some recommendation they process with data as such. It's not very extraordinary in terms of achievement. But the second reason why AI has become so popular is that, AI, like many disciplines, is progressing in a linear way. Not at all according to this exponential jump that people are telling, those bullshit things like singularity or whatever. So we're doing it in a very linear way, but there are some thresholds, and those thresholds are human performance. When you do 1% less than your human, it doesn't make a buzz, doesn't make a high. If you do 1% better than the human, then it creates a difference, even if you have just 1% difference. And that is what happened with AlphaGo. This is what happened with deep learning. Deep learning is doing image recognition better than the neural networks before, but it's just 2%. So in terms of science, in terms of conceptual science, it's not such a big achievement. It's normal, we just progress linearly. But those thresholds make a difference. The autonomous car, I was working on the autonomous car in the 80s. The autonomous car is working better now than the 80s. Just that 1%, will drive better than the human driver. So that is the 1%. But the third reason is more interesting, according to me. We are tending a big bifurcation between 2 AIs. And these 2 AIs is usually what I call the conscious AI and the unconscious AI. And this bifurcation has never been as big as today. All right? They always existed, those 2 AIs. If you want, the unconscious AI is more neural networks, and the conscious AI is more planning, problem solving. Since the 50s, the bifurcation was there between the 2 AIs. But the gap has never been so big that today. So let me first try to differentiate those 2 AI for you. So 3 examples of the 2 AI. Well, my slide are not exactly like I wanted, but you can understand. So first, take society gaming. Well, not so fast. Take society gaming. I'm not going to explain the Go, it's too long, it's too complicated. But tic-tac-toe is a very easy game. You all play tic-tac-toe. So you have to align 3 crosses or 3 circles. Well, there is one way of playing for the computers, is to play against itself many random games. And by a statistical compilation of the winning games, you would realize that it's better to place, if the computer has to learn to play, it's better to place the cross in the middle. Just statistically, You know, you just go and do random games. And this is exactly how AlphaGo is playing. It's playing against itself random games, okay? And statistically, it just learns what are the best moves. This is unconscious AI, because this game has not the least clue of what is the rules of the game. You know, you could play this game exactly, you could play the tic-tac-toe exactly like the Go, or exactly like the chess. It's different, and excuse me for this slide, it's not going so well. It's different. What I'm teaching to my students, the first thing I'm teaching to my students when I'm teaching AI is the min-max algorithms. And the min-max to play the tic-tac-toe is a bit different. Whoa! The min-max is a bit different. You play somewhere the cross, and then you see what your opponent is doing, and when you see what you're doing, and you see what your opponent is doing, and then you have the different configurations of the game you achieve at the end. And then what is really important, if you put an evaluation, you put a score on this configuration. And you know how you have to put a score? You need to have some expertise of the game. So you need some human expertise in order to put a score. This is where humans play a key role, you know. And this is how the Deep Blue machine beat it, Kasparov playing chess. We needed human expertise. For the AlphaGo, you don't need any human expertise. If you want AlphaGo is this way, and Deep Blue, the chess player, is this way. Here you need an expert, you need a human expert. Let me take the second example, the autonomous car. Well, the autonomous car, I did it in the 80s. You know how I did that? We put a camera on the back front of the car, and we just took pictures, snapshots of what the car was seeing. And we registered what the human driver was doing. And then we created, today you have to call it the big data. At the time you used to call it the database, but now you call it the big data. We compile the many action perception of the human driver. And with those things, you teach a neural network to drive exactly as a human being. You have no clues that you're doing the driving. You just have a database of perception action, and you make the neural network learn. Once the neural network is able to replicate the human drivers, you substitute the human drivers by a neural network. To some extent, it's not exactly like, but it's a little bit like how the autonomous driver is doing. This is not at all what a control engineer will do. This is what a control engineer will do. Don't ask me to explain that, you know. You have to make a mathematical process of a car, you have to make a mathematical process of the objective or whatever. But this is much too complex for using that kind of approach. So again, the human expertise disappears due to the complexity of the problem. Third example, automated translation. So suppose you try to enter a French sentence, too fast. You try to enter a French sentence in your favorite automated translator, Google Traduction or Google Translate. And you get this sentence. Well, sorry, it doesn't fit exactly right. Après ce plat de fayoum, mon arrière-train sifflera 3 fois. Well, for people speaking French, it makes sense. Sorry for Flemish friends. But if you put it in a Google Translate, you have after this dish of baked beef, my hindquarters frizzled 3 times. Doesn't make sense. What is interesting is that before automated translation need a human expert in order to extract semantic feature or in order to extract syntactic features. With those syntactic and semantic things, you go in a huge database. And then if you use a real linguist or the automated version of a real linguist, like a Noam Chomsky if you want, you have to extract things, and then you process data, and then you can approach a right translation. This is not at all how Google Translate is running. Google Translate has a huge database at its disposal with any traduction that has been proposed since the origin of humanity. And then once they want to translate something, they just look in this database, they do a learning machine, again, deep learning. We usually call it a neural network in the 80s. Now you have to call it deep learning, just a semantic games. And you use this learning machine, you put the sentence, and if in history this sentence was already proposed somewhere in a book, and the translation had been already done somewhere in history, then it will just replicate what the human translator has done in the past, without having the least clue that this is a translation going on. So really important, understand that in the first case, the unconscious AI, you learn, you use data, you use human expertise in big data, but you don't need human expertise, explicit expertise. So what is the big difference between those two AI? Well, the conscious one, well, you need to sequentialize your knowledge. Sorry. You need to decompose the problem. And why do you need to decompose the problem? Because you need to simplify the problem. Why do you need to simplify the problem? Because you need to explicit and exploit human expertise. You need to have a human in the loop. The human will gain computational power, will make it simple, then you need this human expertise. This human expertise, so you still have brute force. Everything a computer is doing is brute force, nothing else. You still have to brute force, but the brute force guided by human knowledge. Human knowledge makes the problem easier for the computer. This is no more the case. In the unconscious AI, well, you can use all those terms, big data, machine learning, parallel processing. It's blinded brute force. You still have this brute force, you know, like the neural network learning to drive, like the neural network learning to translate, like the neural network learning to play tic-tac-toe, to play Go. You don't need any human expertise because brute force is enough. So, this is my two AIs. Well, and obviously, I was telling you that there is a third reason why AI is becoming so popular these days, is because the unconscious AI is doing so well. I have no problem to tell that this unconscious AI is doing so well, and is doing so well because big data. We never had so much data than before. And also we have algorithms which are doing, you know what is the difference between deep learning and neural networks? Well, before, when we use the neural networks, we need a human expert to extract some interesting features to put in the intermediary layers of a neural network. We don't need those human experts anymore. The automated extraction of the features is indeed automated. The neural network by itself learns what are the important features that help the image recognition. So we bypass, we eliminate again the need for any kind of human expertise. And this is typically, this is a Google way of explaining deep learning. You have an image recognition process where you try to differentiate dog and cat. You put that in the neural networks. You put trillions of images of dog and cats, and at the end, you'll be able to automatically differentiate a dog from a cat. And in fact, the achievement is pretty impressive. This is one of the last achievements of IBM and Google. For instance, here you automatically label image, which is quite impressive. No problem with that. And how you can do that? Because you tag these images and you create again such a huge database of images that you can feed a neural network with those image and automatic labeling, and the neural network will learn to automatically label an image. When I was telling you that AI didn't invent anything, in the 50s, this was 2 slides, exactly like I'm doing right now, 2 slides of the 50s. This is deep learning, invented by Frank Rosenblatt in 46, 7, I think. And this is Arthur Samuel using a reinforcement learning to play not the Go, but to play checkers. But his reinforcement learning to play checkers was exactly the same as AlphaGo. It didn't have the power, but conceptually it had exactly all the ideas. So this is the reason why I'm not so enthusiastic about deep learning or AlphaGo, because conceptually nothing is really new. Sorry to tell you that, but this is the problem of being old. You just listen the same story again and again. So you have 2 AIs, one I call conscious and one I call unconscious. And it's not so distant from what we have as human beings. You might have read this fantastic book, not by an AI expert, a cognitive scientist called wow, just press 1 this time, I don't know. Called Danny Kahneman, Fast and Slow. You read this book? And Danny Kahneman told, but we know that in the human brain, we have 2 types of cognitive processes. We have one, which is laborious, sequential thinking, that you use when you do problem solving. And he used to call it System 2. We're not very good in System 2. And System 1, which is automatic, unconscious, parallel processing. This differentiation, this distinction between those 2 systems, he used to call it System 1, System 2. But look at that, conscious, unconscious. Instead of calling my 2 AI System 1 AI or System 2 AI, I could have called them, instead of calling them conscious and unconscious, I could have called it System 1 and System 2, but it's exactly the same idea. But there is a key paradoxical difference. We human beings, we try to rely as much as possible on System 1, the unconscious one, because we're pretty good. When we do driving, we don't think about driving. When we bike, we don't think about biking. So we try to rely as much as possible on unconsciousness. But once we have a problem, once we meet a situation that we're unexpected, that we didn't expect, then we have to become conscious. We have to become conscious in order to resolve the problem. You know, I'm trying to understand, I normally click those things unconsciously, but since I have that problem, I try to understand what's going on, and so I make some conscious reasoning in order to deal with that problem. So once you're faced with an unpredictable or unsurprising event, you have to become conscious, okay? And this is a way to explain the jump between unconscious and conscious in human being. Well, in the machine is the other way around, you know. We are attending a situation where AI used to deal with conscious machine when the problem was easy, but now that the problem becomes complicated, they try to rely as much as possible on unconsciousness machine. You know, facing this complexity, they need a lot of data and a lot of unconsciousness. So the machine is becoming more and more unconscious for dealing with complexity, while in exactly the same situation, for dealing with complexity in general, maintains to increase its consciousness. So the problem with machine consciousness, I only see one problem. Well, it's okay, this does, you know, it works perfectly well, this unconscious machine, but there is one big problem, it's an unconscious machine. So it can't self-explain, it can't explain what it's doing. And can we accept to put an unconscious machine, a machine which is not able to explain why it takes that decision? Well, no big deal for playing Go. You know, you play Go, you don't have to explain why you make this move. But it's different when you put an autonomous driver, or when you have a software piloting a drone that's going to kill a soldier. Then it would be better to understand, because I believe that responsibility has something to do with accountability. Our machine needs to be able to explain what we're doing. By relying more and more on unconscious software, we're losing this self-explanation possibility. And this is one of the most worrying situations that we're facing today. Thanks for your attention.
Thank you very much, Hugues. I think it's the first presentation of artificial intelligence started with tic-tac-toe. It's a very good explanation about conscious and unconscious IT, artificial intelligence, where man tend to lead to conscious and machine just the other way. It's a very interesting topic. Now we go for the hors d'oeuvre for half an hour, and then we come up with 2 other speakers. See you soon.